How are you all? Welcome to my channel Aim Chemistry, Learn Chemistry with Dr. Poonam. In this video, we will explore how to calculate Ka and pKa values for weak acids, which are key steps to understanding their strength and behavior in solution. So student, we will start with problems. Calculate the value of Ka for methanoic acid. Solution, this is the concentration of methanoic acid and pH is 2.90. So again students, same way, first reach up to equation of Ka. So write down, you can directly also write down equation, but here interesting thing is that if your formula for Ka is equal to, because you have to calculate Ka, H plus square and concentration of methanoic acid, formula for methanoic acid HCOOH, so it is HC double concentration of methanoic acid. Interesting thing is that student, your formula for Ka include H plus, but in problem H plus is not given, pH is given, pH is 2.90. so from this pH first we will calculate H plus concentration, and that formula also we know, we already calculated in my video. pH is equal to, we know this formula, H plus concentration. So if I rearrange this formula to calculate H plus, so it will be 10 to the power negative pH. So what is pH? 2. So 10 to the power negative 2.90. Directly put it into calculator student and you can calculate. It is equal to 1.26 into 10 to the power minus 3. This is H plus, so mole per cubic decimeter. So you can check your answer student, 1.26 into 10 to the power minus 3. Now you got your H plus concentration. So now you can use this value H plus concentration in this equation, that is Ka is equal to 1. When it is a weak acid student, you should know this formula. So after knowing this formula, and again don't forget to put this square for H plus, and concentration of acid is given, that is 0.01. calculate directly, you will get value 1.59 into 10 to the power minus 4. Next problem, if 0.1 molar solution of weak acid gave pH 4.2, calculate the hydrogen ion concentration and the value of acid dissociation constant and pK. Again same problem student, from pH, because our formula here any weak acid you can take. So formula for Ka will be equal to H plus square. Any weak acid, general weak acid, we will take Ha. So to calculate this, because concentration of acid, molar solution means student mole per dm cube. So directly concentration is provided, but instead of H plus, pH value is provided. pH is equal to 4.2. So if you want to calculate H plus, so put this formula, H plus is equal to 10 to the power negative pH. So 10 to the power 4.2. In calculator it is equal to 6.31 into 10 to the power minus 5 mole per dm cube. And now after getting this H plus, put into this equation. So is equal to 6.31 into 10 to the power minus 5 square, and concentration of acid is 0.1. So it will equal to 3.98 into 10 to the power minus 8. And after calculating Ka students, you need to calculate pKa, and as we know that pKa is equal to negative log to the base 10 Ka. So log of 3.98 into 10 to the power minus 8. Calculate the students. you will get answer 7.4. So near about 5 problems we discussed about calculation of pH, calculation of Ka, pKa, and calculation of H plus concentration also for weak acids. So you need to keep this in mind. Again, one more time I will write formula. If you are using formula, pH formula for strong acid, student, directly write down formula is equal to pH negative log to the base 10 H plus concentration. You will get strong acid, because and here always keep whatever concentration of acid is equal to concentration of H plus ion. So directly you need to put concentration, you will get. But when it is weak acid, you need to use one extra term, that is dissociation constant. Formula is equal to H plus. First you need to calculate H plus concentration, which is equal to under root of Ka into concentration of acid. So after calculating this you will get H plus. After calculating H plus, students, you need to formula pH negative log 10 H plus concentration. From this formula you will calculate pH for weak acid, but before that you need to calculate concentration of H plus, because this is dissociation is incomplete, so concentration of acid is not equal to, see, in this case, student, concentration of acid given is not equal to concentration of H plus. But in case of strong acid, direct concentration, because it is complete ionization, so whatever amount of acid is there, it get dissociated into H plus ion. So you can directly use this formula, but in case of weak acid you have to use another formula and then after pH formula. So student, thank you very much for your patient listening. In next video we will start buffer solution.